I'm very pleased to be here with you. And I'd like to say thanks to Wojtek for accepting my proposal, but he's not here any longer. Maybe he is somewhere around. On the daily basis, I work with Microsoft Azure Cloud, and basically that's the title I have. So this session will be pretty much related to what Microsoft does. Not necessarily, the project is not necessarily Microsoft owned. It is open source. But I'd like to get you familiar with this new concept. Maybe you will find it useful. Maybe you will find it interesting. The level of this session will be pretty much, I would say, on the intermediate level, just to get you introduced to this one, okay? So the agenda for today, I will describe what is Keda. Then we will get into the architecture of Keda. So what are the basic components? How does it work behind the scenes? Later on, we will talk about the available sources for scaling, what is already implemented, what is in progress, what is planned. And at the very end, we will touch the base on the HTTP triggers. And that's an interesting story. OK. Before we start with Keda, I just wanted to talk about the Kubernetes for a while. So you heard probably a lot of things about the Kubernetes yesterday and today. So basically, according to the Gartner research, by 2020, there will be 50% of enterprises running containerized applications, mission-critical applications. And then a huge majority of them are already orchestrated. And of course, the leading orchestrator for containers is, of course, Kubernetes, right? So based on the Microsoft research or based on the Microsoft statistics, the consumption of containerized-based applications is growing like 75% year to year. So there is a huge growth. And we can expect more and more every single day. And why Kubernetes? Obviously, because of this portability. You can run it in AWS, GCP, or Azure. You can run it on premises. Actually, almost everywhere, like IoT devices as well, right? So that's one thing. The extensibility, there is number of commercial and open source projects you can easily plug in. The quality is kind of different. Sometimes they are major projects. Sometimes these are quite innovative projects, but combined all together, or maybe combined consciously all together, will give you a great, I would say, result at the end of the day. And self-healing, based on the, or thanks to the architecture of a Kubernetes, it is able to automatically scale. It is able to automatically recover from failures, from node failures, from pod failures. And that's probably why there is such a huge adoption for Kubernetes, right? Oh. OK. Now, when it comes to Kubernetes, obviously, we have a number of master nodes. We have a number of worker nodes. So we are pretty much limited to the scalability of these nodes, right? So we cannot talk about the serverless in this, let's say, classical approach of Kubernetes, right? Then Microsoft initiated a project called Virtual Kubelet. It is now part of the, it is under Cloud Native Computing Foundation at the moment. And of course, in Azure, there is a custom implementation called ACI, which is Azure Kubernetes, Azure Container Instances. And you can find similar projects in, for instance, AWS called, what's the name of it? I just forgot for now. It's a Fargate. Yeah, that's the name of it. So the difference is that instead of just providing a set of nodes, you have number of, or maybe you provision a virtual node that in theory has unlimited number of CPU cores, unlimited memory, and we are simply scheduling the pods to that virtual nodes. And we can easily get or maybe cover bursting scenarios, for instance, right? We don't really need to wait for the cloud infrastructure to provision next and next node. It takes like a couple of seconds, minutes maybe. With ACIs, these containers are added to the as a pods constantly to our, let's say, cluster. But the problem with this approach is that they are mostly based on the CPU metrics or the need for adding the container. What if we wanted to drive these containers, pods, based on the events that come from outside of a cluster, right? So another alternative approach in Microsoft is Azure Functions. And again, you will find a similar tools in other leading cloud providers. So there is AWS Lambda, there is Google Cloud Functions. They are purely event-based. They are purely event-driven, queue-driven. You can connect number of sources that actually add these instances that process our events, right? But that's not a Kubernetes thing. So to kind of answer this, or maybe to fit into this, I would say, market gap, Microsoft, together with Red Hat, started a open source project May this year. And the name of the project is Keda, which stands for Kubernetes-based event-driven autoscaling, right? So it brings the Azure tooling, like everything you can do with Azure Functions, like a piece of code that is running inside of the cloud. It brings this capability to the Kubernetes cluster easily. With all the tooling support, with all the components, with all the scalers that are already supported, you can easily run it inside of a cluster, right? And of course, you can find this project under GitHub, Keda Core Keda, if you're interested in details. And when to consider Keda? Of course, the adoption of Microsoft Cloud is quite large. It really depends on the research, but it's like a first, second on the market. And then if you are running Microsoft Functions or Azure Functions, then what if you wanted to kind of unify your DevOps and deployment, I would say, processes, or maybe experience, right? What if you wanted to run functions on the IoT edge devices or on premises or in the hybrid scenario? And that maybe answers the question why Red Hat is so much interested in contributing to this project. That basically gives them the ability, especially to the OpenStack platform, to run Azure Functions in here, in there, without the extra, I would say, effort, right? And then what's the architecture of that project? So this is picture source from Keda project. So in general, we have a big component called controller. I will get into details of these elements on slides later on. But in general, we start with the typical Azure Functions tooling, a CLI or Visual Studio Code, whatever type of tool you're using. You're implementing this Azure Functions, its logic, and later on, you pack it into the container, and the container is orchestrated by Keda. So the controller, first of all, is based on a custom resource definition called scaled object. Then Keda itself has number of sources. I will get into details what are these sources available. And it produces a custom metrics. So every single time you define in your scaled object that, for instance, add new pod every time that number of queue messages reaches, let's say, 10, the scaler through the controller will publish a custom metrics, and that custom metric is then taken by horizontal pod autoscaler to add new pods that process our messages, our items, right? And of course, all the tooling is the same, so you can easily use kubectl to see, to manage all the pods and resources, right? So the controller stuff, as I mentioned, there is CRD, scaled object. Controller is, of course, operator that is constantly monitoring the CRD. Every single time you add it, it will respond to that. And the HPA is, of course, driving this pods from 1 to n. But the main purpose of this controller is also to ensure that If there are no events available at the moment, it will scale to 0. So there will be no pods processing our events. And if there is something reported by the scaler, it will add the first pod, it will start producing custom metrics, and HPA does the rest of the thing, adding more and more of them if they are needed. Right? Then when it comes to scaler, so for each and every source we would like to support, there is a class in the Keda project that supports this type of scaler, and we have just 3 methods to be implemented. And of course, the most important two is getMetrics specs for the scaling. The second one produces the custom metrics definition, the one that is used by HPA. And the first one is used to pull the metrics by the controller every single time. We can define inside of the scaled object what is the pooling interval. Let's say every 10 seconds we check what is the metrics, what is the number of queue items, and if we are above, we are taking the action, right? And that's a good place to show you what is the scaled object and how it looks like, right? So in our case, we have a pretty easy definition of an object. We have a specification of the scale out. So the important parameters are the pooling interval, as I mentioned. Every X time we will check for metrics. Then I think these numbers should be exchanged there in proper places. But in general, after this, let's say events are processed after a period of time, then we have a cooldown period. After that period, if nothing new appears on the queue or no events are produced, then the scale over process will start to kill the pods one after another, right? And of course, we have the ability to define what is the minimum number of replicas, what is the maximum number of replicas here for our queue processing. Then the second part is, of course, a deployment reference. So the definition of the deployment that will be brought up to process the upcoming events, incoming events. And the last thing is the trigger definition, and that definition varies. Every single source has a bit different, I would say, set of properties like connection strings or maybe subscription in your cloud, maybe Redis list information, what is the list of items we would like to connect to, right? And now a short demo, a very simple demo, just to show you how easy it is to install the Keda with the functions tooling. Please let me know if you can see my screen easily. Like, okay? It's fine. Okay. So what we can do, we'll be using a functions tooling. And this is basically a CLI that gives you the ability to create the functions from the command line. So you can initiate the project, you can define what is the type of the event for the function, and that tool is used to provision, let's say, functions to the cloud, to Azure, right? Inside of the functions, we have a dedicated Kubernetes set of commands in the CLI. So long story short, if we say function Kubernetes install Keda, this will do the trick, right? So basically, it creates of course, custom resource definition, scaled object, of course, scale account with role bindings, all the security stuff, and a single service called Keda, right, with a deployment. So we can also run this command with dry run option. And you will see all the definitions that are actually deployed. This is pretty straightforward thing. And the Keda, of course, will be listening inside of our cluster and will be constantly monitoring the scaled object CRD for upcoming, let's say, elements, right? Just to go to my presentation quickly, I will show you the real scaled object later on. So what are the sources available at the moment? So, of course, they started with Azure sources, first of all. So we have typical queues from Azure: storage queue, service bus, and event hub. If you're not familiar with Azure, event hub is I used to describe it as a big hole in the wall, quite similar to Kafka, for instance, when you have like stream of events and you have the ability to process them, to respond to them, etc., etc. Right? They also support AWS Cloud, CloudWatch, and SQS, a number of open source projects such as Kafka, RabbitMQ. Also, Prometheus is supported with custom written query about available values. And the new thing that appeared later, a couple of weeks back, is the Redis lists as well. And I mark this HTTP triggering as a, let's say, with a question mark, because it is and is not supported by Keda. I will get into the details later on, right? So what is going, what is planned and in progress? The contributors are looking for people who actually would like to help on, for instance, AWS Kinesis, but they are currently developing a number of other Azure sources. The IoT Hub is something similar to Event Hub, but intended for IoT devices, so with extra handshake authentication for events flowing from IoT devices. Also, the Cosmos DB. Cosmos DB is a NoSQL database supporting number of shems like MongoDB shim, like Gremlin API shim, or Cassandra. Azure Monitor, this is to watch on Azure-specific metrics, like what is going on, maybe the VM is down, maybe something is happening extra inside of our cloud environment. And durable functions, these are stateful Azure functions available in the place as well, right? And when it comes to these definitions, as I mentioned, the trigger definition will be a bit different for each and every source. So in this particular case, for instance, we have a Kafka. You need to provide what is the list of what is the address of our Kafka. And of course, we need to provide what is the threshold, what is the producer group, etc., etc. Same with GCP, same with Prometheus. In this particular case, we need to implement the query against the Prometheus. So the number of requests per last, let's say, 2 minutes. That's a good example on how do you add this pod to support your metrics from the Prometheus. And just to show you how it works in real environment, I prepared a quick demo. This is a bit more technical demo compared to the previous one. That was only to show you how to install the Keda. In this case, I provisioned a storage queue in Azure. So this is a simple empty queue. And I have a command line application just to send events to that queue, right? I'll be sending just 3 types of the events: red, blue, and green text strings. Okay. Then Keda will be provisioning pods. This will be Azure functions we will implement all together on the screen. And the only let's say, functionality of that function is to get the event and execute the post HTTP post to our, let's say, front end that is also running inside of the Kubernetes. What the front end does, front end simply fires a firework. Every single time it receives the red, let's say, message, it will fire the red firework, green firework, blue firework, and etc., etc. Okay, let's see it in action. And again, let's see how easy it is to implement it. So I have the empty project. Keda is already installed. I did the installation just a few minutes back. So first thing we need to do is the command palette. I would like to create the Azure function. It will be here in the demo folder. In my case, it will be JavaScript function. And of course, I'll be working with Azure Queue Storage, as the example says, right? The queue trigger, we can go with defaults. I will connect to one of the subscriptions I have in Azure. So that's the name of a cluster. I need to specify the queue. In this case, it will be named Keda. And here you go. We have a very simple function that will be able to respond to this queue events. One thing I need to do, I need to provide the Azure Job Storage connection string. So I will just copy paste it from here and get it into here, right? Of course, save it. And now the code of our JavaScript. So I have it prepared. Okay. So in this particular case, we will perform a post request, as I mentioned, that sends the color information to our frontend. And of course, it communicates internally with our Fireworks web pod. Okay. So here you go. So let's open the Keda demo. That's our, let's say, reporting layer for our events, for our processed elements. So I will keep it open. Extra thing we need to do, we need to initiate the Docker container in our functions, because by default, the function tooling targets the Azure, right? Then we need to change it into container. So it is performed by function init Docker, and we are happy, right? So we got the Docker file here, a very simple one with Azure Functions already. All the tooling already added, installed inside of that Docker. And what we need to do, we need to install the this function to container, right? So we have a function Kubernetes install. No, that's not a thing. Okay, I'll write it. Function Kubernetes deploy. Name of our functions, it can be queue trigger. And I need to provide a name of my registry. Okay. So we are now running the build. It will be pretty fast because I have all the images cached. So it will just take a couple of seconds, I hope, to get it built and pushed to my Docker repository. Okay. Of course, secret to keep my connection string safe, and deployment of our scaled object. So now we can take a look how the scaled object looks like. kubectl describe. So here you go, all the elements we mentioned. Actually, you can add these extra parameters to the deploy command, saying what is the minimum, maximum number of pods, what is the pooling interval. These are elements you can add with extra parameters. And the interesting part is, of course, a trigger configuration. And in this case, we have queue trigger, connection string, source from the secret. And we are ready to go at the moment, right? Nothing else, just scaled object and the definition of our deployment. And of course, we can do kubectl just to monitor what's going on with our pods. Okay, as promised, I have a send to queue, and we can say red 25 reds, right? And we should see them pretty much popping up here. Just give it a sec. that's a famous, I would say, cold start when the image needs to be taken from the Docker registry for the first time, right? At the same time, we can see that Keda is adding the pods supporting our queue messages, right? And of course, we can get it even worse easily. Blue, 50. Let's add green, 40. So it's warming up, right? The green is not yet there. Maybe I mistyped it. Oh, okay, that's why. So let's repeat this exercise. 40. Okay. Is it adding new pods? I hope it does. More of them. Yeah, but in general, you can see a huge scalability of this thing. You can easily process hundreds of messages. Then when we go back to this ACI concept with virtual kubelet, when we have this unlimited, let's say, virtual pod, we can change the deployment with annotations to actually target all these pods to virtual kubelets. And in this case, we don't really put the workload to our initial, let's say, set of nodes that is running maybe more important elements. We can easily scale them to ACIs and will be just charged for a second of the execution of this particular pod, right? So this is more or less how it works. And the other thing we can take a look into is, of course, the HPA. I mentioned there is HPA. And as you can see, we have get HPA queue trigger. So every single time we deploy the scaled object, control takes care of it and publishes its value to the HPA. So the HPA does the scalability 1 plus n, right? Okay. Any questions at this point? How about the HTTP triggers? So the HTTP triggers are a bit different in this case. So the main concept of Keda is to bring, I would say, event-driven, queue-driven, metrics-driven scalability. It basically pulls the metrics from the scalers every single time, but HTTP workloads have a completely different characteristics. They work on the opposite way, I would say, right? That's why Keda itself does not implement any HTTP scalability. However, it tries to address this by saying to the customers or maybe to people who actually use it, they say, okay, if you want a Keda, you can do Knative serving, or you can use Osiris. And that's a funny, interesting thing, because Osiris is probably the project you don't know at all. Pretty similar to Keda. It runs on the very same or very similar. It takes the very similar approach. When compared to Knative, it doesn't depend on Istio. You don't really need to install number of elements to your cluster. And rationale behind not including HTTP triggering functionality to Keda is that they wanted to create a small scoped project that is purely event-driven without the HTTP elements. But actually, from the other side, they wanted to satisfy all the customers who would like to bring these Azure functions that do support HTTP triggering. And that's why they kind of combined both, right? Then the other research says that in Azure, when it comes to Azure functions, about 60, even 70% of functions execution is event-based. So they really wanted to focus on these events only, right? Then the Osiris project, the one that is installed by default together with Keda. So it has a number of components. And of course, it is installed by func Kubernetes install in the same way as Keda. But in this case, we don't really need to provide any //Keda, but it simply installs everything, right? So in this case, each and every pod that is going to receive the HTTP traffic, HTTP requests, gets a sidecar container from Osiris project, and that sidecar produces the metrics about the CPU utilization, whether we need more pods to actually support this traffic, or maybe we are fine with the CPU utilization we have in place, right? That's one element. Then after the containers become idle, so we can imagine there are no HTTP requests any longer, the zero scaler observes the metrics of our sidecars, or collects the metrics from the sidecars, and simply says, okay, we don't need any more container to support this HTTP traffic. It scales to 0, right? Then to be able to respond to anything that comes with the HTTP traffic with 0 pods, it is a bit challenging thing, right? So in this case, it will create or maybe it runs the endpoint controller that adds a activator for each and every scaled object, or for each and every, let's say, definition or function we would like to deploy. So we add a function, it gets the activator, and the endpoint controller is responsible for hijacking, adding these activators, right? And the story begins when the HTTP traffic comes back to our cluster. So the activator creates a very initial pod in Osiris, and then metrics collected by sidecar on top of that pod start to stimulate the HPA to add more and more pods to support our incoming traffic, right? Okay. So in this case, I'd like to show you how it looks like from the cluster perspective. To be able to install it, of course, you can install it with Keda, or maybe with Funks tooling. Whoa. So what you can do just Funk Kubernetes install, and it will, of course, Kuber. Okay. So this time without the Keda switch, so it adds a Keda back again, but also creates all the Osiris component. You can also run it from Helm chart, for instance. On the Osiris project website, there is a description on how to install it with different tools as well. An interesting fact is that the current Funks version, so the functions tooling I just installed, doesn't scale, right? So, and I find this out during preparation for my demo. So it is able to scale from 0 to 1 pod. Now I can load test this single pod. Of course, it will degrade in the performance. Of course, it will respond to the request at some point, maybe with latency of a couple of seconds. But let's say these open source guys, mostly Microsoft guys, forget to maybe test it out properly. So I need to say I am really surprised after researching around this. But in general, it should work. So let's see what are the pods we have. Actually, I can deploy a new functions just to support it for you. Okay, let's do it. We can do new folder, demo number 2. And again, functions. So we go to our command palette. Other functions, create in demo folder. It can be C# for, it doesn't matter actually. HTTP trigger. Let's name it like this. Let's do the anonymous function.
Right.
Okay, and what it does, it simply expects the get HTTP request, and in that get request, we expect the query parameter name, and the query parameter name will be exchanged to the text replayed back to the requester. again, we need to run the terminal to do func init Docker this time, force. So we have a Docker file. And again, we can put whatever implementation of our functions we would like to. But for demo purpose, I don't think we need to implement something sophisticated. We just want to test it out, right? So in our case, it will be I will deploy it back to our cluster. Thanks, Kubernetes. Again, deploy. Will be name HTTP trigger this time, and the registry of mine, right? So what we can see here, it simply builds the Docker image. Hope it will go smoothly. Yes, perfect. Okay. Okay, we have a secret, we have a trigger, deployment and service already configured. Let's check whether we have the service. Okay, actually I forgot to remove it, so I already have the external IP for that. So let's do it like here. We have the IP address, just to double check. It's the same. Okay, so we have hello Knight native, right? So it simply responds. We can, of course, run the load test to see whether it scales, as I mentioned, because of the, let's say, the version of the Osiris that is installed together with this function init command. We are, I would say, couple of versions behind the original, I would say, commits in the project. So that's why it doesn't support the scalability later on. But what we can see, of course, we can see the pod being available in here. Yep. So we have HTTP trigger pod available. And of course, we could wait like a minute or two, so the zero scaler notices the fact that there are no new events upcoming to our pod, and it will bring that pod down and will deactivate the stuff. Later on, we can also create a request. There is no ingress controller, nothing else. It will simply create a pod for us within a couple of seconds, I would say, right? So that's basically it. Yep. Okay, so let's wait a sec. I don't want to keep you here. Okay. So as you can see, by leveraging this Keda functionality, you can bring the Azure functions easily to Kubernetes. Without any problems. The only problem is HTTP trigger. I hope it will be fixed sooner or later. Actually, I'm wondering to maybe I should just report that issue and simply change the version of the Osiris that is installed together with a tool, because this is just a couple of, I would say, commits up, and that should work. So with all the workloads that are function-based, if you are considering to create a hybrid environment, if you would like to somehow consolidate the deployment of your applications, if you would like to avoid a situation that you have a range of microservices running in Kubernetes and maybe set of functions that are kind of acting as a glue code in between events happening inside of your infrastructure, I think Keda is a very interesting project and the easy way to go without extra dependencies like Istio, like number of pods. It simply adds a single deployment, single pod, single service to your cluster and is able to, let's say, support this Azure Functions workloads, right? Okay, it didn't die, not yet. Okay, so you can trust me, like a half a minute, it will be deleted and we can try over again and we will see this pod being created back again for us, thanks to the Osiris project, which is just glued together with our Keda installation. Okay. And basically this is everything from my side. I'd like to say thank you. I hope the level of that session was not that low, not that high. The intent was to just show you what is that Keda project. It is extremely simple in my opinion. So that's why we didn't have a chance to get into like a solid details, like difficult elements. Easy project for running functions in the cloud inside of the Kubernetes. Thank you.
My question is, what was the business case for you to start working with Keda?
What was the business case of start working with Keda? So as I mentioned, if you have, so that's a basic scenario. If you have, or maybe if you are rooted in Azure, right, you end up with number of not necessarily unified type of deployments in different places. You have, maybe you initially start with platform as a service called web apps, right? Then you consider moving from this PaaS environment into Kubernetes cluster, right? And then there will be a question, okay, how do we support all these events? How do we support all these small functions we actually deployed to our, let's say, in our projects? How do we move them? Of course, you can say, yeah, we don't really want to move them, but if your management or if you as an architect would like to say, we would like to consolidate, we would like to run on Kubernetes entirely, right? This will be the project that will help you to kind of, let's say, make a switch. The other use case is if you'd like to run the same functions in different places, so not only in Azure, but in different places, like on-prem installation of Kubernetes, maybe a company has this requirement that we would like to support this type of things in 2 different places. That's the way to go as well.
I noticed that there was a field for, let's say, different kinds of objects that were autoscaled by Keda. Mm-hmm. How flexible it is?
What do you mean? Flexibility about the scaler?
As in what kind of objects it could scale? Because the demo had a deployment.
Yeah.
But could it scale other objects? Let's say I might have a CRD which handles some complex set of applications.
So from my experience, I haven't seen any other deployment type of the object it scales but the deployment. Actually, when you take a look into the scaled object definition, you will see that there is this triggering part, the scalability part, and the reference to the particular deployment, right? Not like other types of the resources.
So essentially it's like future-proofed for that, but not yet.
Yeah, so just to make it clear, so Keda was, I think the first commit, or maybe it became public May this year. So this is still something that is not fully supported on the production. So, and you ask about the use case, right? So in my case, this is not yet there, right? Especially after I tried this out for HTTP trigger, I noticed this is not the best moment for Keda, at least for this HTTP scalability, right? But when it comes to events, it behaves stable, in my opinion. But as I said, it is not yet fully supported on the production, right? And maybe the new elements will appear later on in the future.